Hello dear student, welcome to another lecture on C++. So far we have learned about what a C++ program is, what are the features of a C++ program, what is the structure of a C++ program. We have learned about some built-in features such as libraries, header files, functions, etc. We have learned how to give input and how to extract output from C++. We have learned about some of the data types that we use in C++. We have learned about variables and constants and how to declare a variable and define a variable. And also we have learned some of the methods to manipulate our outputs. In this video, we will be talking about operators and expressions. Especially we will be looking into arithmetic operators, relational operators, logical operators, and shorthand operators. Operators. Operators are functions defined to do certain specific operations. There are many operators that we use in C++ such as arithmetic operators, assignment operators, logical operators, relational operators, bitwise operators, shorthand operators, and much more. Arithmetic operators. Arithmetic operators are used to perform arithmetic functions such as addition, subtraction, multiplication, division, etc. We will look into some of the operators that we commonly use. The plus sign is used to add two operators. If A is equal to 10 and B is equal to 20, A plus B will give 30. A minus sign subtract the second operand from the first, and A minus B will give negative 10. Here A and B are called operands, and the plus or the minus sign is called the operator. Again, multiplication we use a star sign. For division we use a slash. For modulus operator gives the remainder after division such that B divided by A, that is 20 divided by 10 will give 2 with no remainder. So the operator will give a value 0 because it has no remainder. An increment operator, that is 2 plus signs, or a decrement operator, that is 2 minus signs, are mainly used in conditional statements. We will learn more about conditional statements in our next video. Such that just remember that conditional statements, these operators are used to increase the value of the given operand by 1 or decrease the value of the operand by 1, such that A plus plus will add 1 to A, that is 10, and give an answer 11, where A minus minus will subtract 1 from the A and give an answer 9. Now we will look into the relational operators. Before that, why can't we give a small example on arithmetic operators? Let's try making a simple calculator. You are already familiar with hash include, which is a preprocessor directive. IOStream is a header file. Using namespace standard, main or int main, and within the curly braces, we can declare our variables. I can either declare my variable with an initialization by giving an initial value, or I can declare a variable without giving an initial value. Now I am declaring my variables here with an initial value. So it is initialization and my variables are A and B. I have to declare one more variable so that I can extract output. I declare another variable C without initialization. And let it be Cout. I need to get a small line a free line before this, so I give int L. I define C is equal to A plus B. And towards my operator side, Cout, I type A minus B is equal to C. Again, I change the value of C such that A minus B, sorry, I made a mistake here, it's A plus B. And C is a variable which doesn't have an initial value or which is not a constant. So I can change the value of the C over many times inside my program. I need not define separate variables for separate functions. I can use the same variable with differing values. A minus B is equal to C. Again, I take C is equal to A star B, which is A multiplied by B. Cout enter A multiplied by B is equal to C. Let's try with the modulus operator also. A modulus B, this have to be B, A modulus B, and remainder of A divided by B is equal to C. Let's try to compile this program and see if there are any errors. There are no errors, it's ready to compile. And here we go. A plus B is equal to 30, A minus B is equal to negative 10, A into B is equal to 200, and the remainder of A by B is 10. Sorry. Now moving on, as the remainder of A by B is 10. Yeah, it's good. It's running fine. And now moving on, we can look into relational operators. We have done with arithmetic operators, so we can look into relational operators. Relational operators are used to find the relation between given two numbers, such that if the numbers are equal or the same, if the numbers are not equal, if one number is greater than the other or less than the other, such that relations between any two numbers are found using relational operators. Two equal sign will check if the operands are equal to each other or not. If it is equal, then the condition becomes true. Then one exclamation plus equal to sign checks if the operands are equal or not, and if the condition becomes true when they are not equal. A greater than sign checks if the first operand is greater than the second, and the condition becomes true if the first operand is greater. And the less than operator checks if the first operand is less than the second, and the condition becomes true if the first operand is less than the second. A greater than or equal to operator will check if the right hand operator or the right operator is either equal to or less than the left hand operator. That is, if A is either greater than or equal to B, then the condition is true. And the same way we can use less than or equal to operators. Let's check this with another program. Let me delete this once and try starting another program. And here let me declare my variables before without initialization. And I don't think I would need another variable. A and B will be enough. So I'm gonna declare, say I have to get the values for C and A and B. So I have to give a Cout. Let me give a line there. Cout. Oh. And the numbers. In is used with the extraction operator and Cout is used with the insertion operator. Hope you remember. Now let me check if these numbers are equal to each other. So I am giving a statement here. This statement if is known as conditional statement. And we will learn more about conditional state. Time being, just understand that plus program. So here I need to check if A and B are equal. A equal to B will check if A and B are equal. And if this statement becomes true only if A equal to B. Cout. Numbers are equal. Else Cout and numbers are not equal. So if this statement is right, this is called an if-else loop or if-else conditional loop. And if this statement is right, then the program will get into this loop and will perform the function or will give the output which is defined here. If this function, this statement seems to be false, that is A is not equal to B, then the program will skip this step and come to else and do whatever is mentioned here. That is, if A is equal to B, the answer will be numbers are equal. And if A is not equal to B, then the answer will be numbers are not equal. Let's try compiling this. Now I have to enter two numbers. I enter 2 and 3. The numbers are not equal. Now try with some equal numbers. I enter 1 and 1. The numbers are equal. And this is how this works. A plus equal to means if the numbers are equal or not. if we change this with an exclamation mark, this shows that not equal to. So here it will be numbers are not equal. This statement will be true if A is not equal to B. And if A is not equal to B, it will get enter into the if loop. If not, it will get out of the if and perform the function which is defined under the else. We will learn more about if else. For the time being, let's check two numbers. The numbers are equal. Let's check another. Numbers are not equal. Likewise, you can check any of the functional statements such as greater than or equal to, or greater than or equal to, less than or equal to, or any of the relational operators here. I leave it unto you. Try these operators and come out with results. So let's move on. The next operators are logical operators. What are logical decisions? Such as in digital electronics, we make logical decisions with the help of binary numbers, that are zeros and ones. And logical operators are operators those work with the zeros and ones. You are familiar with a logical operator such as and, or, not, etc. Such that and, if two operators and is used, the operator and will become true. That is, operator and will give an answer equal to 1 if both the numbers entered are equal to 1. Hope you remember the truth table of and, or not. And will become true, that is, and will give an output 1 only if both the inputs are 1, or will give you an output 1 if any one of the operator, if any one of the input is 1, and the not will reverse the operations. Hope you are familiar with the truth table. So let us try this by doing another example. We can try with, say, enter the inputs. Here we have only two inputs, zeros and ones. So enter the inputs. If any one of the input is high, then OR will give a high, and if both the inputs are high, then AND will give a high. So let's check with the operator AND. And for AND, I have to give two AND symbols. A and B. If A and B is equal to 1, we will obtain only if A equal to 1, B equal to 1. So if this is true, then this conditional statement can be modified as the operator is AND. And the else statement as the operator is not AND, because we are not sure whether the operator is or not in this case. Let's try this. So the AND operator will be true only if both the values are 1. The operator is AND. For any other values such that 1, 0, the operator is not AND. Another value 0, 1, the operator is not AND. And for 0, 0, the operator is not AND. Again, try with OR operator. The OR operator has the modular sign. Operator is OR. Operator is not OR. Let's try this. The OR will give a high if any one of the input is high. That is, if both the inputs are high, then the operator will give a high. If A is high also, the operator will give a high. If B is high also, you will get a high. And it will give a 0. It will give a 0 only if it is both the operators are low. Sorry, in this case also operator is an OR. In this case you can say that both the numbers are 0. Because the operator remains the same. Both the inputs are 0. In the previous case, you can change the else into any one of the input else 0. Move on. Assignment operators. Assignment operators are used to assign. Assignment operators are also known as shorthand operators. They are used to assign a value to a variable. We have already seen assignment operators. We have given C is equal to A plus B, and here equal to is an assignment operator because we are assigning the value of A plus B is included into the C. We are assigning the value of A plus B into the variable C. So equal to is an assignment operator. There are many other shorthands such as plus equal to, that will add the operand and that will add the operand with the value which is stored in the variable and assign it into the same variable, such that if C has a value 3 and A is given a value 5, then C is equal to C plus A equal to A will give 3 plus 5, that is equal to 8. Again, minus equal to, it will subtract the right operand from the left operand and assign the result into the left operand. A star equal to will also multiply the right operand with the left operand and assign the value into the left operand. Similarly, you can do with division equal to or modulus equal to. Let's try with an example. I am trying to make a geometric progression or an arithmetic progression. So for arithmetic progression, Cout, enter the difference. the difference C in my variable is A. Now I assign another value C equal to A. Let it be my first value. Now Cout handle C, and I wish to give a tab here, that is a horizontal spacing. It is a special character, so have to be given inside a single quote. Now again I can change the value of C plus equal to A. Cout C with the tab. Again C plus equal to A. Cout C tab. Once again Cout plus equal to A. C plus equal to A. Cout C a tab. Let's try compiling this. No errors. I mark my difference as 5, and here I get my arithmetic progression 5, 10, 15, 20, and I would have get more if I added more steps. Now let's try to make a geometric progression. The geometric progression, instead of common difference, we get the common dividend. That is, the product or the divisor between the two numbers will be the same, or the product common product will be the same. So in this case, I just need to change this by a star sign. And try compiling this. Let the difference be 5, and each number will be multiplied with 5. That is 5. Here we have 5 into 5. Here 5 into 5 into 5, etc. And this will give a geometric progression. Hope you are clear with the relational or the assignment shorthand operators. Likewise, you can do many other operators or operators which are mentioned here. Now let us look into expressions. You have already seen many expressions, so just put it into words. For example, you have given C is equal to A plus B. That is an expression. Here A and B are operands and plus is an operator. So expression is something which contain an operand, an operator, and a variable to which it have to be assigned. And that is x equal to something, or A equal to B plus C, or something. That is an expression. We have done many expressions, so just put it into words. C++ expression consists of operators such as plus, minus, division, modulus, etc. It contains constants such as numbers 2, 3, 5. You can add C is equal to 2 plus 5. Then 2 and 5 are constant, plus is an operator. It can contain variable. The expression can contain variables such as A, B, we have already seen, which are arranged according to the rules of the language. Again, C++ expression consists of operators, constants, and variables which are arranged according to the rules of the language. It can contain function calls even. We will see about functions and function calls in coming lectures. An expression can contain more than one operands, such as in the given example 2 by 3 into 4, the division and multiplication. Here we have two operators and here we have three operands, that is 2, 3 and 4. So the expression can contain one or more operands, 0 or more operators, and it can compute a value. Again, every expression produces some value which is assigned to a variable with the help of assignment operators. Here equal to is an assignment operator. Division and multiplication are arithmetic operators. X is equal to 2 by 3 into 4. 2, 3 and 4 are constants. The division, the slash and the star are operators, arithmetic operators. Equal to is the assignment operator and x is the variable. In the next example, z is equal to x plus y. Here x and y are variables, predefined variables. And equal to is an assignment operator, plus is an arithmetic operator, and z is a variable to which the value of x plus y will be stored into. Bool y is equal to a greater than b. We know that Boolean have only two values, that is true or false. So Boolean y will be true if a is greater than b. Here greater than is a relational operator. Equal to is an assignment operator. Bool y is a variable and a and b are also predefined variables. So by this we come to the end of this lecture. Hope you are clear with operators and expressions. I encourage you to do more and more exercises with operators and expressions demands. Thank you.